Welcome to all. Myself Saranya, working as an assistant professor, Department of ECE at C.SARANYA College of Technology. In this video, we are going to see about Boolean difference concept in VLSI testing and verification. Boolean difference is a type of deterministic method for finding test vector. Using this method, we are able to find all possible test vector. This is the block diagram which indicates the Boolean difference concept. In this circuit, this block diagram has two kind of blocks, that is defect free block and defective fault circuit block. That means fault free circuit, faulty circuit. So in this circuit we are giving our inputs for both kind of circuit, that is fault free circuit and faulty circuit. From this circuit we are going to find output. That output is compared with our XOR gates. When XOR gate produce 1 means at the time we are able to find test vector, else we are not able to find test vector. Hope everyone know the concept of XOR gates. When both inputs are same, that means 0 0 1 1, output is 0 for XOR gate. Both inputs are different means at the time the XOR gate output is 1. So based on this concept only we are able to find the test vector using Boolean difference method concept. Next, move to next slide. Consider this is example circuit. From this circuit, in this circuit y is affected by stuck at 0. Stuck at 0. Already we know the concept of stuck at 0 and stuck at 1 concept. So in this circuit y line is affected by stuck at 0, and from this fault we are able to find test vector using Boolean difference method. So before this we can write expression of this circuit. What is the expression of this circuit? F equal to x dot y, f equal to x dot y plus y bar z. This is the expression of this circuit. So from this circuit we are find the test vector when y line is affected by stuck at 0. So now already we discussed, based on the XOR concept only we are able to find the test vector. That means Fy means fault free circuit output, XOR, then faulty output value. Compare with XOR gate, suppose it produce 1 means we are able to find test vector. So this is the same concept. Fy XOR Fy bar equal to 1 if only if Fy and Fy bar result in opposing logic values. This is the logic of Boolean difference method. So here Fy XOR Fy bar equal to df by dy. So from this concept only we are going to find test vector. Already we discussed y line is from previous circuit, and y line is affected by stuck at 0. So at that time we need to initialize our node to 1, that is node y to 1, that is opposite value of stuck at 0. Suppose y line is affected by stuck at 1 means we need to initialize our value equal to 0. So here we consider y line is affected by stuck at 0. So at the time we need to initialize that node y value equal to 1. This is the logic to find test vector. So same circuit. In this circuit our expression is f equal to x dot y plus y bar z. From this circuit we are going to find two kind of value, that is f of y bar. So f of y XOR fy bar equal to 1. This is the condition of Boolean difference method. From this condition, based on this condition only we are going to find two kind of value, f of y and f of y bar. So here write fy equal to x. That means here y in this expression you can substitute y equal to 1. So y equal to 1 means y equal to 1 means, wait, y equal to 1 means f value equal to x dot 1 plus 1 whole bar into z. So f equal to 1 dot x equal to 1 plus here 1 bar equal to 0. So the invariably the term value equal to 0. 0 plus x equal to 0 plus x equal to x. This is the fault free circuit output value. Fault free circuit output value. That is written as fy equal to x. Then next step is to find fy bar. That means here we can substitute y equal to 0 in this expression. So at the time fy bar equal to z. So now we found two kind of value, that is fy and fy bar. So why we want to find this both value? Based on the Boolean difference concept is fy xor fy bar equal to 1. This is our condition of Boolean difference method. So only we are going to find this kind of two expression, that is fy and fy bar. Substitute this expression in our condition. That means next condition, y equal to y dot into df by dy equal to, already we know y value, then d of f divided by dy, but that means fy xor fy bar. So y dot, y here written as y, because y here our main aim is to find fault affected by stuck at 0 at node y. So we consider here y. Based on this only remaining fault to find another possible lines in circuit. Okay. So here y dot, here write y dot f, what is the fy value? X. Then xor, what is the fy bar value? Z. Okay. Substitute the both value in this expression, that is fy xor fy bar. So substitute our expression. Finally we can get this expression. That means x bar dot y dot z plus x dot y dot z bar. Okay. So from this expression we are able to find test vector. We are going to write test vector of given fault. That means y at stuck at 0. Y node is affected by stuck at 0. So here what is the expression? X bar into y dot z plus x dot y dot z bar. So from this expression we are going to write this test vector. What is the x bar? Written in the form of Boolean value, that is x bar means you can write 0. From this term converted in the form of zeros and ones. Okay. That is x bar written as 0, y is directly written as 1, because this y value is not considered, not has y bar, any value of bar. So directly written as 1. Also similarly z value written as 1, comma, another term of our expression x dot y dot z bar. So x directly written as 1, for y directly written as 1. Here this term considered z bar. In this term x z value considered bar value, that is written as 0. This is the output test vector when node y is affected by stuck at 0. This is the concept of Boolean difference method. Based on this concept only we are going to find test vector. Next we move to next slide. Similarly, suppose our w line is affected by stuck at 0. So based on the previous concept, here we are going to find test vector. So already we know the concept expression of this circuit, f equal to x dot y plus x dot y, that means, wait a minute, here written as x dot y plus y bar z, okay, but in this slide directly you can write x dot y plus w, okay. So what is the from this expression, what is the our two steps? Suppose that line is affected by some kind of fault, that is either stuck at 0 or stuck at 1. From this for this line we are able to find f of w and fw bar value, okay. So first step is to find f of w, that is fault free value and faulty circuit expression value from this expression, okay, from this expression. So here first we find fw means you can substitute w value equal to 1. What is the what is the value? That is f equal to x dot y plus w. So in this expression we substitute w equal to 1. So f equal to, that is fw equal to x dot y plus 1. Already we know the Boolean's law, that is 1 plus anything equal to 1. That is only here written as fw equal to 1. So next step is to find f of fw bar. That means here we can substitute w equal to 0 in this expression. That means f equal to x dot y plus w. Substitute w here. F equal to x dot y plus 0. F equal to x dot y. This is fw bar. This is fw bar. Okay. This is the fw value, bar value, fw value. That is we found two values, f of w and f of w bar. So already we know the Boolean difference concept, that is w into df by dw. W dot df by dw, that is written as w into f of w xr f of w bar, that is written here, okay. Already we know the f of w value, fw bar value, both already we find that expression. Substitute that value in this expression, that is what is the w value? W equal to y bar into z into 1 xor x dot y. Simplify that expression. Finally we can get x bar y bar z plus y bar z. That is simplify again, it is simplify this expression. Finally we can get y bar z. So from this expression we are going to write test vector. So already this circuit has 3 inputs, but this term consider only 2 labels. One missing label is x, missing input value is x. So when we going to write this vector, we write all, that is a 3 input value, okay, that is x, y, z. So that is equal to, so in this term not consider x value, so that value is written as here x, that is unknown value. Y bar written as 0, z is written as 1. This is the test vector for stuck at 0 at node w. The post fault stuck at 0 is affected at node w. This is the test vector for given fault. Next we move to next slide. This is another kind of fault present in the same circuit. That means the z node is affected by stuck at 0. If a z node is affected by stuck at 0, similarly we can find the two kind of value, that is f of z and f of z bar, but both values here x dot y. So here both values are same. Already we know the concept of XOR gate. Both values are same means produce that XOR gate value equal to 0. So when XOR gate produce 0 means we are not able to find the faultest vector for given circuit. This fault is known as undetectable fault. Hope everyone got the idea about Boolean difference method. Thank you.